Right. Okay, that is horrible. So, but it's better than what happened on Linux. So I don't know. So it looked like it was live, but the only thing that told me it was not live was this right down here. Yeah, you can see it on stream. This went down to 0 kbs a second. That's the only thing that said it wasn't live. But everything else said it was live. So that is so at least then I can close OBS and open it back up and start the stream. That's much quicker of a turnaround. Still though, man. Maybe I just need to buy an NVIDIA GPU or something. I don't know. Or just get my Intel laptop out and just start programming. Ah, what a pain in the butt. So maybe the buffer overflow won't be fine, but maybe a infinite loop might be okay. It's bloody horrendous. Oh, thank you for the Ko-Fi support there, I'm Campaign. Appreciate it, sir. Welcome, welcome. Um, so what are we going to start on today? So you know we have that profiler, right? We need to get it working on Windows because we're not seeing it. So I think in the graphics, well, GPU. No, GFX.c. Without it's without the PP, just C. So we have a profile thing. We just dump out to we do a printf. We do have the logging system, so we could just use that and have that. I think we use the Windows subsystem for Linux on Linux to do that. I think that's all we do. Let's see how well that'll look. So we have like a new log. Cool. Right. So we got the shaders one. Let's do graphics profile. And then so that we just need a tag names. So we have these things called tags, and basically each tag gets a file. So we can just literally open up that file and just see the profile information. Maybe we'll call it profiler. And then that ought to be good enough. And then we should just be able to use that. It's a very simple system. We basically, when we build up the log system, we go over all the tags, create a text file for it, open it up, and then whenever we log to it, we just obviously, just we just actually log directly to that file. It's nothing complicated. So really, you want to have one thread accessing it at a time, right? And that's what we do there. That's all we really need for this game, hopefully. So we just need to say core log, and you probably just want to say debug or debug log, I guess. I don't know. And then we'll just effectively just do all of that. So I think we might. Yeah, so the problem is I think it needs to get rid of these new lines because it's going to go ahead and put in they'll put the level in there, then it puts the file. Yeah, okay, then it puts your content. Yeah, we'll do that. It's alright. A bit. Maybe we should have an option to say, do we want any of this? Or maybe we don't care. Maybe we should have an option to say, hey, do we want the option should be called something like disable location. Or So maybe just call it like log mode, and we'll just have 2 log modes for now. The default will be 0. So the log mode log format mode, I guess. So you have like a format mode of so the default one you want effectively like a full, and the other one will just be basically just like the message only. And maybe you might say, oh, I want to show the level on the message or something like that, or maybe it should be a bunch of flags. Yeah, so you want, so the ones that you want to disable, thing like that. I don't know. Yeah, or, yeah, maybe like format flags, I guess. Flags. So you want to say like, show the message. So you always want to show the message. So there'd be like a level, and then you want to do show maybe like the location of the file and that, right? And then the other one is, wait, that's it, isn't it? So I guess the other one is probably full, and that'll just be a combination of them. Maybe you can have more stuff and it could be more configurable. But I think that's a good improvement at least. So just do full for the rest of them, and then the other one just has like none. Better than none. Oh, yeah. So this way you can view the profile information. It should hopefully be good enough to do it this way, I hope. Format flags. So you just want to copy the names one, and then we'll just man, I feel like I'm programming in the Stone Age. Just like the way I navigate on the keyboard. Like my hands like a claw. Just around all the control keys. Whereas with Vim, it's just sort of splayed across the whole keyboard, and you've just got all your shortcuts at your fingertips. Because otherwise, you just have my pinky on the control key, and I've done that too much to the point where my pinky has like RSI now. So I have to like use my main fingers around the control keys. It's much nicer that way. So that's kind of why I switched to Vim, because it was just, you know, less of my, not use my pinky so much. So this one you want to use basically none. Um, or message only. Maybe we can call it message only. That's all I want to see is the message, and then when we're just in the log, we can just go, oh, do I want the level? Oh, do I want the location stuff? So you just do something like, oh, it's not called tags, is it? Yeah, it seems pretty good because that's one of my biggest problems with using a log system is you get all this sort of garbage on stuff sometimes when you don't want it. So seems like it's a decent idea. Always put those brackets around people. Get bit in the butt. And this one will be location, I guess. Yeah, maybe just care about the file sometime. If we did, we can change that. But location, sorry, file and line can just go together. Oops, wrong one. My brain was thinking about that for a bit. Okay, that we go. So just the level string, please. Um, so I guess I want to say if you've had any of these, right? Um, I'm skipping ahead. My brain's going too fast. Yeah. So you might need to put a gap between there. Let's put a space, and let's put a space there. That'll do it. So then we want to say, okay, if you've got anything in these format flags, then what you want to do is put in a pipe. And then that ought to be good enough, I reckon. So now we should be able to just run it, and our profile is going to go to this profile thing, profile log file. In theory, you should be able to run it. Oh no. Whoops. Copy paste. Oh, what a T here. So what we'll have is this in the build file I've got a log and what this profiler is called now. Yeah. So here's there's all the stuff in it. We shouldn't see all this prefixy stuff. I thought I removed that. So clearly we are seeing things we shouldn't. So I just said message only. That is 00. Oh, we did it with the level rather than with the tag, isn't it? Whoops. Yeah, that's why it's sometimes nice to have arrays which can have like a type safe with an enum sometimes, but yeah. But anyway, but it's okay. It's only really bad if you overflow. But you don't really overflow too bad with enums anyway. Rightio. So there's our boy. So this is what we're seeing on you know on our Arch Linux install. We were seeing this stuff, right? So now we just want a nice way to view this. So what we set up is, we use the Windows subsystem for Linux, and we've set up a nice thing. It's called wlog. Right. Yeah, it's called wlog, and it basically CDs to our directory. It's an alias for something. I completely forgot it. If I nano into the dot bash rc or something like that. Is it bash rc? Yeah. It is simply this alias wlog. So we cd into our directory and then we use watch with a 0.1 ms refresh rate, and it refreshes that and it tails the last 15 lines. So that's all it is. So we just say wlog and we just say gfx profiler.txt, and we're literally seeing it now. And if we just run it, we should be seeing a live update. So that's a system that we're basically doing. So yeah, this is cool. We can just keep it open and we just be like, oh, how is it? And we just analyze it here. So it's actually running a bit slower than it was on my other than it was on Linux. Yeah, it's interesting. Right, so now we can actually get on to what we're doing today. Yeah, it just stays open. Just have a look at it. It's all cool. Obviously we can't scroll up and see what it was like we could in Linux because it was a proper terminal. But oh well, this would be good enough. So we're going to be doing some BVH construction. So I think it was RCT or maybe some other folks as well were referring me to this at some point. We was doing that sort of planning, planning how to do our we was planning on seeing how we could sort of like accelerate our ray tracing, and I was planning on building a BVH. And the way I was planning, I've lost my Milton, damn it, because it's on the other operating system. But the way I was planning on building the BVH was via some sort of like sparse grid and sort of slotting my spheres into this sparse grid. Very terrible idea, by the way. And basically, having grids of certain sizes and smaller grids inside the other grids or whatever. Very terrible drawing, and would slot the spheres in there and launch all these threads that just put spheres in there. And the reason why I wanted to put the spheres in some form of grid is so we could have them near each other and sort of like be able to sort of process multiple, have a bunch of threads that process a bunch of nearby spheres. Turns out it was a very terrible idea, but it's just because we actually tried to implement it. We tried to plan it out on how we would implement it with compute shaders, and it wasn't really possible. But we read this. Well, I read this outside of stream, and it has this quite interesting thing where you basically use the Morton curve, the Morton Z curve, to effectively like translate from Morton space into a linear 1D coordinate. So yeah, so Morton curve space is this, and it can go in 3D as well. So basically you can take a coordinate, a 2D coordinate or a 3D coordinate, and map it into a 1D coordinate, and going back the other way, right? You take a 1D coordinate, turn it to a Morton coordinate. So why is this useful? Because it does this sort of Z curve with the so you go sort of up, then diagonal down, up, and then it resets, and then it does that again in the next sort of place, and then it does it at this sort of does it at the micro level, but then also at the macro level. Every single time you reach one Z at the macro level, it does it again. Like it literally does it outside. So as you can tell, so it does it even more of that as well. Do another one of these 4x4s up here, and then another one of those 4x4s down here, and another one of those 4x4s down there. So basically, if you take a pixel, a 2D coordinate pixel or 3D coordinate, and you turn that into a Morton, and you turn that from Morton curve space into like this linear 1D space, you basically get them all sorted next to each other. Effectively. Sorry, you have a number, which means you can sort them all next to each other. And that's what this one of the interesting points this one takes away. So you don't have to do any sort of binning into grids or anything, which is cool. Yeah, there's the Hilbert space filling as well. That's the other one, isn't it? But I think that one's more complex. Like this one, the beauty of Morton is that you don't need a loop. You can basically do it with a bunch of instructions, like that. But I'm not sure how, because although I haven't really looked into Hilbert spacing too much, but that's the impression that I got when I looked into it. Hey, the caller Maz. Hey, joining the stream for the first time. Is there an FAQ on why you're doing this with computer shaders? I love programming and doing everything with graphics programming, but everything graphics programming is a nightmare. Yeah, that's part of the reason why. I have got a video where I sort of go over the whole. If I can go to. Yeah, on my YouTube channel, there's like a devlog 0 where we go over the project as a whole and what we're doing. I haven't posted there in a while because I literally don't have the time. But there's also. But yeah, the short end of it is graphics APIs are really overcomplicated, and it would be nice if we didn't have to use that, and if there's a way where we could just use compute shaders and just do graphics that way. Obviously, it might not be as fast as the sort of doing it using these graphics APIs, but we're also trying to make sure that we're not going to be rendering triangles. We want to try and do some sort of like, so we're rendering a whole bunch of spheres, and that's our sort of more unique, or that sort of is, trying to be a little bit more unique than other games where they use triangles. Maybe have some sort of different art style that uses just spheres everywhere, basically. So we're just trying to find a way to see if we can make it look good and also it render fast enough. So by using compute shaders, our graphics abstraction is dirt. It's dirt like simple. Stupid simple. That's the word. So this is a whole like OpenGL like API. It's like 300 lines at most, including profile information. We're basically just able to launch a compute shader, synchronize on a resource, and start an end of frame. We've got some read back utilities to read back with automatic copying as well if we want that, or manual copying. We've got uploading. We've got resources as well, like images and buffers and stuff. So that's all we really need. So it's trying to think if we can sort of get rid of basically everything and just render using compute only. That's the idea. You probably wouldn't want it for graphics, but it looks fancy. I'm not sure that. Oh, the Hilbert space. Yeah, it does look. It looks kind of cool though. Yeah, but maybe you do want it for graphics, right? You get some sort of nice pattern. But let's just visualize that for folks who weren't really familiar with it, and can't be bothered to. Why? Right, I was slightly off from the keyboard there. Hilbert curve. That's what we want. Yeah, so it looks like this. You get some really cool pattern. Like it's pretty fancy. Maybe you can build like a maze out of this and sort of like knock a wall down or something, or like or color stuff in this way. Whatever it is, right? There's probably many interesting things you can do with this that I can't really think of right now. Gaussian splitting. Yeah, I've seen the Gaussian splitting stuff. It is pretty cool. But I don't know. It still goes over my head how they're rendering it. It look, yeah. Like every time I read the paper, I'm not quite getting it still. So the basic idea is we can sort our spheres by this Morton curve, right? So we basically like, this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we sort all of our spheres by this, right? And then that means we should be able to construct a BVH with the sorted information very easily. So the BVH is just a binary tree, basically. Because you're sorting them by position in the world, right? So that means effectively you can just take the two that are sitting next to each other, put a box around those, take the two that are next to them, put a box around those. I should be drawing this on Milton. Right, the idea is if you put, you got two in space, right? So this would be Morton 0, this would be Morton 1, this would be Morton 2, this would be Morton 3. So you put a box around these two, right? You put a box around these two, and then these two go in another box, right? And so it's like a tree system where you've got like this one, and that one, where this box is that one, this box is that one, and then this outer box is this one here, and you're basically just building a tree out of all of that, right? And that's all this. That's all we're doing is building a binary tree. So that's one of the things that this paper says, but I don't think this paper sort of came up with that. What this paper came up with, that was already present in a previous thing it was saying or that it was referring to. What this one takes away is you can actually do some highly parallel version of this LBVH thing that it was referencing or something. Where you can basically do this in a highly parallel way. Um, at first, I don't think I'm gonna copy this exactly because it actually is a little bit complicated. It requires some sort of like binary searches and stuff. I think you can do it even in an even more simple way, and I want to try that first, and then do their sort of more complicated way, so I can sort of visualize what it's actually doing. Because I'm not, I think I understand what it's saying, but I don't fully understand it, and I want to visually see it. So I'm just going to drop it in there for those folks who want to sort of study it a bit more. Right, so what we're doing now. So the thing we want to do is actually just build a model, right? A simple model that we can use to sort of like automatically put the BVH thing, or the BVH stuff around. So I think I could just do another rectangle again. Well, 3D rectangle, whatever you want to call that. It's probably a cuboid, isn't it? I forgot what it's called. Thank you, Tarasco. Thank you, appreciate it. There's a bunch of blurry discs angled, so they form 3D shapes. Yeah, I've seen that, but it's like I don't know how they're doing the actual rendering of those. But yeah, I know what they're doing. They're basically rendering like ellipsoids, right? Something like that. 3D ellipses. And they, yeah, I guess blur them. Yeah, it's pretty cool. Okay, so what are we trying to do now? And why is there two of the same file open? Is that legal? Oh, that's really annoying. Right. Okay. So what are we planning on doing exactly? So we would probably just want to see like a box and um what's the best sort of, because I could just do a sphere. I could see a sphere made up of more spheres. And we just plot them across a grid. Let's use an SDF to get rid of them. That's something we can do. And then we need to sort it by the Morton Z curve. And then I can just give that to the GPU to do the highly parallel BVH build. And then we can run it through our BVH visualizer, which we've seen, right? So I'm just trying to think, because we just want to visualize it using this sort of thing we've got, right? So if we have a sphere on the screen, it might be a better shape to see, or we could just construct something highly out of SDFs. We could literally have like a 3D sort of box, just like a cube or something, that we have some SDF in there and just construct this sort of weird shape that's maybe got like, maybe we can just see it in 2D. Just some simple test shapes. So I think we might want to say like, well, I want like, you probably want to see something going across horizontally, and then maybe let's just do like some some weights or something like that. So you do spheres on the left and right. You got this sort of box that goes here, and you just doing like lifting some big ass weight, right? And then you're seeing sort of straight lines, but also curved, and maybe you can get to something like that. So we can just create something like that in Shader Toy using SDFs, and then sort of create that model at some resolution of filled with tons of spheres, and then we can then run the BVH builder through that. I think that would be ideal. That'd be cool. There was a game in the 90s that rendered mostly with ellipsoids, was it? Have you got a link to that at all? Okay, so I think what we can do is we can just simply go to like, look for IQ. Well, okay, 3D SDF functions. I can never remember how to spell IQ's name. So we basically want to just get a sphere with a box. I think this is going to go to the same one, isn't it? Oh, that's the YouTube video, the same test seen on the... We just want a simple, like... Yeah, perfect. Just take something like this. And so we'll get rid of the rotate. Where's the scene? There's T. Create ray. EU. Camera matrix, right. That's it. AN. Perfect. Boom. You're ours now. So we just want to take this box. So this is box frame. Let's get rid of all that. Put in the sphere. And then we'll put in like this as well, this SDF box. So we'll just basically just fudge something together. And then that. So we just want to take, where's the frame?